Hello everyone, my name is Pritam Paul and welcome to another video. And in this video we are going to discuss about pointers. This is the third lecture, and in the previous videos I have discussed about these parts, like how we can write pointers and how it actually works and all. We have written some codes as well, as you can see here. So in this video we are going to enhance the pointer concept and what we are going to do. Okay, so yeah, so what we are going to discuss about the dereference operator first. Okay, so we all have seen, let me write the code first. Okay, so integer a equal to 13, for example, and we are writing integer asterisk p equal to ampersand a. That's cool. But can we write float? Yes, we can write floats here as well, like float f equal to 34.6, for example, and we can write float asterisk fp, for example, equal to ampersand of f, for example. Okay, and we can print f percent d and percent p backslash n percent d, then percent p backslash n, and this is the way we can do it. Correct. Here we can use asterisk p as well, and here you can use asterisk fp as well. Okay, and you can return. Here you can see, so 34.599999 is coming up. We can do one thing, 0.1 we can give, and yeah, so 34.6, and the address is printing out, and 13 and the address is printing out. We can see that. Correct. So now this is good, obviously. But yeah, so now what we can discuss, okay, let me go to this part and let me write this few commands. Like, for example, if I write asterisk p1 equal to 9, and after that if I write, for example, asterisk p1, okay, one second, asterisk p1 and then plus plus, actually it means, okay, and after that, for example, if I write x equal to asterisk p1 plus 13, for example. Okay, and yeah, I would say these are the enough things. So yeah, so what it means obviously, like, for example, if p1 is pointing to any places, like this is p1. Okay, and this is, for example, this is a variable called a. So a, inside this we can write 13, and what will be the address here? It will be, for example, 110. uh, this 110 will be stored here for sure. Correct. So 100 will be stored here as well. Correct. So yeah, yeah, so it will point, what it will do, that it will point to this variable. Correct. So if I write asterisk p equal to 9, then what will happen? 9 will be here. If I write asterisk p1 plus plus, what will happen? So it means actually a plus plus, the uh, postfix operator. Correct. Prefix and postfix. If I write here x equal to this, then what will happen? That means x equal to what? X equal to will be asterisk p is 9 plus 13, so obviously there are no bytes, so 22. Correct. So this is the way it will happen. All these things, kind of operations you can do. Okay, yeah, so now moving on, let me talk about some other things as well. Okay, let me give you an example. Okay, so that we can discuss these things. Okay, one second, I have written some codes already. Let's not waste time here. Uh, Let me explain the codes. Okay, so yeah, here. Okay, so here void, if you want to give, if you do not want to give, it's up to you. There is no use of writing void here, it's completely fine. Okay, so yeah, integer a equal to 87, b equal to 4.5, okay, p1 equal to this. Okay, so let me drag the thing here like this, and so here, if I write the diagram, so A will be, for example, A is there, another one is, for example, B is there, okay, and two pointers are there, okay. So let me take one pointer here. Let me take another pointer here, correct? So here you can write integer asterisk p1, okay, and here we can write integer asterisk p2, for example, sorry, float asterisk p2. Okay, so this is one pointer, this is another pointer. Here it is, for example, integer a, and here it is float b, for example. So inside a, the value is 87, the value is 87, and here it would be 4.5, correct? Now if I have one address, for example, here it is address is 100, and for example it is 200. Okay, let me give the addresses as red so that you could understand. So here also it will be 100, and here also it will be 200, which means actually, this is pointing to this, and this is pointing to this, correct? So all these four lines are meaning actually like this only, correct? Now if I want to print the value of p1 or address of a, which is p1, what will be the output? Obviously 100. Okay, now if I want to put why I'm drawing this diagram, so that you could understand that exactly how the things are setting up. Okay, by these four lines actually, these are the diagrams. This diagram is explaining these four lines. Now we are going to actually print it, actually nothing else. Okay, so value of p2 will be obviously p2 address of b, and value of p2 address of b and value of p2 are same, address of a and value of p1 are same. Okay, address of p1, address of p1, this pointer also will obviously, when you will be declaring integeristic p1, it will take also some more space here also. Like for example, here if we write 1000, for example, and here, and here it would be 2000, for example, correct? So it will print the address of these two also. And then if I want to print the value of a, then obviously a asterisk p1, and if you could see here, which I have explained at that time in my this diagram here actually. So asterisk p means what? Asterisk p means asterisk of ampersand of a. We have talked about it, right? So here you can see asterisk of ampersand of a, asterisk of ampersand of b, the way you can print the value. Okay, so let's see, let's run it, and let's see what is the output. You can see value of p1 and address of a is same, value of p2 and address of b is same, value of p1 is different, it is different, correct? So this is 08 and this is f8, don't get confused, by the way. Okay, it is f0 is 04. These are the complete hexadecimal format, addresses are completely different. You could see 87, 87, 87, 4.5, 4.5. This is the way actually it used to be like this. Okay, okay, so now yeah. Okay, so now let's go to another code and try to understand like what are the things. Acha. Before that, okay, let me tell you about this thing also. Like when the pointer is not pointing to anywhere, okay, the pointer is called a null pointer, correct? And if you want to dereference any pointer, you could see p1 equal to null, and you could write p2 equal to null. Okay, and if you want to print the addresses of it, it will work. After putting at null, it will work. But if you want to print the value, okay, print the value, this might not work, by the way. Okay, let me show you guys. Okay, and here it would be Okay, now let me run. You could see uh, address of P1 and P2 are getting printed out when we are trying to print the value of this segmentation fault is coming up. Okay, so that's why actually we cannot sorry we cannot use actually after dereferencing it, the values will not be there because pointer is not pointing to anywhere. It will be zero. Okay, it will be null. It will be null. You can say null means nothing but zero. Okay, so it will be null. It will not be pointing to anywhere. These integers are different. Okay, if you want to print the value, okay, of a and b, it will be printed out. See, hey, once again, let me comment this two first. And see, A and B are getting printed out, whereas asterisk P1 and P2 are not getting printed out because we have dereferenced these pointers. Okay, this is very important to understand. We have dereferenced this pointer, so P1 and P2 are null. That's why they are unable to actually like get the values, because address he lost, his memory I have deleted. It has a, for example, it has a memory of remembering addresses, so I have removed the memory, I have flushed up, okay, the memory, and these are empty now. Okay, this cannot go to anywhere and print the values. That's why the segmentation fault is coming up, whereas in case of A and B independently, they can be printed out. So this is the beauty of pointer, I would say. Okay, now if a pointer, okay, and now let me talk about some other stuffs like what is the size of a pointer. If I say what is the size of a pointer, let me talk about that. So I would say let's go here. Okay, so what we have seen here, like size of a pointer of what, like for example, if for example this is the thing, okay, this is a pointer, okay, and we, let me call it as integer asterisk integer, right? So IP, for example, okay, integer pointer, okay, and yeah, this is like this, and let me create some more pointers. For example, float, so we can write fp. चलो double करते हैं, double would be good, I think. uh, yeah, I think this too, and on this character also we can take character as well. Okay, so I'm writing a CP, character pointer. Okay, so now the thing is like what will happen. Okay, so let me take this example. Okay, so so obviously, yeah, like this. Okay, now let me copy and paste here as well, and here as well. Correct. Now obviously integer will take 4 bytes, that is for sure, whereas in case of double, and it is character. Okay, in case of double it will be 1 2 3 4 5 6 7 8. Okay, and in case of this one it will take only 1. Correct. So integer pointer is pointing to an integer actually. Correct. These 4 are actually, we can make a group of it, and this 8 we can make a group of it. Okay, so this is pointing to actually here, and this is pointing to actually here, and this is pointing to here. Cool. Chalo. Now for example, like what will be the size of the pointer? So this is the size of the integer actually. Okay, don't forget, this is the size of the integer, this is the size of the double. So here it will be 4. Correct. Here it will be 8, and here it will be 1. Correct. But what will be the size of these pointers? What exactly they are storing? Are they storing any values like which will be like which are there in these 8-bit bytes or 4 bytes? No, they are just simply storing the addresses, like address of a, for example, address of an integer, which is actually an integer value. Okay, this is another address of a double value. Hmm. So this is also an address is always a actually address is always a integer actually, correct? So obviously this addresses, all the addresses, if I consider, okay, all these addresses are what? All these addresses are nothing but integers, I would say. Okay, then obviously what will be the size of these integers? Obviously the exact size of the integer which in our C programming actually we take, that is the size of this addresses also, correct? Correct me if I'm wrong. I would say this is the one, correct? So obviously what will be the value of these addresses? 4. Yeah, size of the address is obviously 4. It will take 4 bytes to store any integer value in our C programming thing, right? According to C programming. So in C, what is the size of the integer is 4. Then obviously all the size of the like pointer variables also will be 4. Okay, let me give you an example and try to understand. So if you see here, character a x and ampersand p1 equal to ampersand asterisk p1 equal to ampersand of a for integer, for float, for double, for four of the things. Now we are going to print the size of the p1, p2, p3, p4 along with size of asterisk p1, asterisk p2. Asterisk p1 means what? The variable. These variables actually are asterisk p1, correct? So here what will happen, like if you are getting printing all these values, it will be different. Obviously the difference will be there, but whenever we are going to print the pointer size of the pointers, whereas size of p1 will be there, so obviously it will give us 4. Okay, so it will be not u. Now you can see this is coming up like this. Size of p1 is 8. Okay, not 4, I would say 8. 4 in terms of like in my operating system it is 8. In your operating system it could be 4. It depends on the OS actually. So you can see size of p1, which is actually pointing to a character. It is giving the it is giving us like this one second. Okay, I think now it will be a little bit more visible. Yeah, so you can see size of p1 is 8, whereas the size of asterisk p1 is 1. Size of p2 is 8, whereas size of asterisk p2 is 4, because what? It is integer. In case of float also it is 4, and in case of double also it is 8, and it will remain same for the pointer variables. But when we are talking about asterisk p1, p2 and p3 and p4, the sizes are differing. So that's why I was saying that this size may differ, but whereas these sizes, like these pointers will like take the same size actually. Okay, which is 8 in my operating system. It could be 4 in your Windows, I think. So in Mac it might be 8, I'm not sure. So that's how the thing is. Okay, the size of the pointer actually will be same, whereas the variable where it is pointing to, that differs, that may differ, okay, based on the variable, correct? Now there are few more things. Okay, I think this is this much for today. This video is getting longer, and in the next video we will talk about the pointer arithmetics. Okay, it is very important to understand the pointer arithmetics, and after that, like, many more things will be coming up one by one. So yeah, this much for today, and I hope you are understanding and liking the pointer playlist. Please try to run the codes, and if you want me to put the codes in my like GitHub repo, then I will do it. Let me know in the comment section if you need the code. Okay, I will put it there in my GitHub repo as well. Yeah, so this much for today guys, and see you in the next video.